In this video, I'm just going to run through the answers to the online quiz that you did on ionic bonding. I know that you would have got some automatic feedback when you did the quiz and got your score, but this is just to give you a reminder because it's been a couple of weeks since we've thought about any of this. So we're thinking about, so this quiz is about the bonding in sodium chloride. So we're always going to be thinking about sodium chloride. So in sodium chloride, a positive ion will be attracted to any negative ion. True, all right, because any positive ion is obviously going to be attracted to any negative ion because they're oppositely charged. All right. Now you might be thinking, well, you know, if I've got a positive ion, a negative ion, a positive ion, a negative ion, a positive ion, a negative ion, is this positive ion attracted to this negative ion? And the answer is yes, because they're oppositely charged. Okay, it doesn't matter that there's 4 other ions in between them. Because they're oppositely charged, they are attracted to each other. The thing is, though, is the strength of the attraction depends on the distance. So this positive ion and this negative ion are next to each other. So the attraction between those two is going to be very strong. This positive ion and this negative ion are far apart, and there's lots of stuff in between. So the attraction is going to be weak. All right. The same with light charges. So this one and this one will repel, and this one will repel, but this one and this one repel more because they're closer together. Okay? All right. So a sodium ion is only bonded to the chloride ion it donated its electron to. So when we talk about the formation of sodium chloride, we have this idea of sodium donating its electron to a chlorine atom like this, okay? And then we get the positive, negative, positive, negative, positive, negative, this kind of structure. All right, now it's easy to think that, well, this positive ion donated its electron to this negative ion. So those two are bonded together. But no, the bond, when we talk about the bond is the attraction between the positive and negative ion. So even though, you know, in your mind you might be thinking, well, this one donated to this one, I mean, it's impossible to tell which one donated to which one. The fact is that this positive ion is surrounded by negative ions. So there's one to the left, one to the top, one to the right, one to the bottom, and there's one above it coming out of the paper, and there's one below it going into the paper. So it's surrounded by negative ions. All right, so it's bonded to all of those because the bond is the attraction between oppositely charged ions. Okay, next. So that is false. A sodium atom can only form one ionic bond because it only has one electron in its outer shell to donate. Well, if we look at the answer to the previous question, we can now tell that that is, of course, going to be false. So the problem is that thinking that this here shows the bond. This isn't the bond. This is just how the ions in the bond are formed. All right. The attraction between the positive and negative ions, that's the bond. All right. So if we go on to number 5, the reason a bond is formed between chloride ions and sodium ions is because an electron has transferred between them. No. All right. So the transfer of electrons between them, this thing here, that gives us ions. All right. And then if I've got a positive ion and a negative ion, that's the bond there. Okay. So the reason there is a bond is because you have a positive ion and a negative ion and they're attracted towards each other, and you're going to have lots of them, remember, because it's ionic. All right, so number 6, each molecule, well, immediately, as soon as you read the word molecule in anything to do with ionic bonding, you know this is going to be wrong because there are no molecules here. All right, this is an ionic compound, it's a giant ionic lattice. All right, this is a molecule, that's a molecule of water. All right, this is another molecule of water. This is what molecules look like. Okay, this is what giant ionic lattices look like. They're not the same thing. So this idea of a molecule in sodium chloride, wrong. Okay, you can't think of, you know, I know what you're thinking. You're thinking, well, this here, this is a molecule of sodium chloride. No, it's not, because it's part of a giant ionic lattice. All right, number 7, Ionic bond is the attraction between a positive ion and a negative ion. True. Yeah. Okay. Okay. Next one. A positive ion can be bonded to any neighbouring negative ions if it is close enough. True. Yeah. All right. So I know I said at the start that when we were talking about, you know, this positive ion is attracted to this negative ion, but only very, very weakly. So really, you know, we wouldn't really bother ourselves that much with, you know, is this positive ion bonded to this negative ion? Because it's going to be, because it's so far away, it's going to be a weak attraction. You know, this is the attraction we're interested in. All right. So really, we're only bothered about the ones that are close by because they need to be close by for the attraction to be strong enough. Okay. The reason a bond is formed between chloride ions and sodium ions is because they have opposite charges. True. Okay, that's what I've been talking about for the last 5 minutes. That the bond comes from the opposite charges being attracted towards each other. 10. An ionic bond is when one atom donates an electron to another atom, so they both have full outer shells. No. An ionic bond, okay, is the attraction between a positive ion and a negative ion. That's an ionic bond. All right. This, you know, donating one electron to another, that's how these ions get formed. Potentially. It could happen by another way, but, you know, generally that's how they get formed. There are no molecules in ionic compounds. True. All right. Don't make that mistake. Covalent compounds have molecules. These are not covalent compounds. These are ionic compounds.